So I'm going to try to tie up some loose ends, things where I see people not quite understanding, but we need to get it to be successful on our next assessment. So one thing is when radians are given as just like a number without a pi. Some of us had a question like that on the quiz and perhaps didn't do so hot on that question. So when we have radians, typically if we go, if we start here we have 0, if we go all the way around we have 2 pi. But if I turn that into a decimal, I have an approximation. 0 or, who remembers that? 6.28, right. And that's an approximation. That is not an exact answer. So halfway around would normally be pi, but as a decimal, it's 3.14. Now those you should be able to get no problem. The pi over 2 up here, the exact pi over 2, the 90 degrees, that one, if you need to find what that decimal is, you just need to divide 3.14 by 2, which is 1.57. And then the bottom one, you'd have to do, I mean, there's like a bunch of different ways you could do it, but you could take pi divided by 2 and multiply that 3 times, or you could take like 3.14 plus 1.57, but this ends up being 4.71. So now if I ask you which quadrant is 5 radians in. So if I ask you that question, which quadrant is 5 radians, that is the same thing as asking which quadrant is 5.0 radians in. So if I say 5.0 instead of 5, do you have a better idea of which quadrant that one's in? Where would it be? Eva, where would it be? That would be quadrant 4. It would be about here, right? So what if I said, how about 3 radians? So 3 radians is just above 3.14. That was not even very accurate, but just above 3.14. That's where 3.0 radians would be, and that would be quadrant 2. And we really have to understand this because in section 4.4, which we're not at yet, you're going to be dealing with a bunch of radians that are decimals. And you have to really understand which quadrant they're going to be so you can make sure you're doing it right. So we got to understand that. So that's one thing. The next thing is, this is in the book, and there's an entire section on the worksheet. So if you have your worksheet open, I'm going to kind of bounce around between a few topics here. But on the worksheet, there is a, start at number 15, I think. It says something like, it's a unit circle. In the directions it says it's a unit circle. It says quadrantal angles, which I haven't talked about that word yet. We've done it, but I haven't used that word yet, so that's why I'm going to go over this. So a unit circle means our radius equals 1. A quadrantal angle is when the terminal side is on either X or Y axis. So there's 4 quadrantal angles in this circle. I'm going to put an ordered pair at each of those places that there is a quadrantal angle. So on the worksheet, there's like this little area where you're going to draw this picture. Like it has the circle and the XY axis there. It says something about labeling. So what I'm labeling is how you should label the picture on the worksheet. So I know my radius is 1, and I'm more than welcome to say this is 1, this is 1, this is 1, this is 1 if it helps me. But it says it in the directions by saying it's a unit circle. And it says to label the quadrantal angles. So before I label them, I just want to talk about their radians and their degrees. We'll do it in a different color. So this one would be 0 degrees, or it could be 360 degrees if you went all the way around. As radians, that would be 0 or 2 pi. And then way over here, we'll either have pi or we'll have 180 degrees. So at the very top, 90 degrees, or that could be pi over, what, 2? And then at the very bottom, it's 270 degrees, or it could be 3 pi over 2. Then it asks you also to label the ordered pairs. So this ordered pair, where that dot is in the first quadrantal angle at 0 or 360 or 2 pi there, what ordered pair would that be? There's enough information to tell me. Yes. So I actually know more than just x0. Caitlin? 1, 0, because it tells me that this is a unit circle. I know the radius is 1, which means the x value is going to be 1 there. Okay, how about this ordered pair at the very top? Grace, could you give me that ordered pair at the top? 0, 1 is correct. And then at pi, Brady, could you tell me the ordered pair at pi? Perfect. -1, 0. Be nicer if I wasn't writing so messy. Okay, and then the very bottom one. Emma, can you tell me the bottom one?
0, -1.
0, -1. Good. So now that section, it's like 15 to something. It's ask. Who has that worksheet open? What's 15? I don't remember. Sine 90? Oh, cosine 90? Okay. So number 15 is cosine 90. So when you see cosine 90, this is telling us directions. This is saying find the cosine at 90 degrees. Okay, but that's a lot of words, so mathematicians shortened it. They wrote cosine 90. But what it means is find the cosine at 90 degrees. So remember cosine, we learned this last time, is x over r. Since it is the unit circle, r is 1, so I could even say that cosine is x. So I go to 90 degrees, and we have an ordered pair on 90 degrees. What is my x value? 0. Guess what the answer is? 0, done. That's how you do that section 15 to 30-something, I think, is you just have to use those ordered pairs and use the formula for cosine, sine, tangent, and so on. Okay? When you get to that section, if you get stuck on some of them, ask. So that is quadrantals, and we did that last time. I just never used those words yet. And then this next one, I think I'm just going to create a new page because I'm writing big. Actually, before I do that, let me go back to this one I was just doing. I do have another question. Who's the worksheet open? Oh, Kevin, you have the worksheet open. What's number 1 on the worksheet? Thank you. So I had some people every single year say sine pi over 6, and please do not write this answer down because it's going to be wrong. Sine pi over 6, they told me, is 30 degrees. Now I just told you that is wrong. What is wrong? Emma.
Pi over 6 and 30 are the same, but it's asking you what the sine of pi over 6 is.
Right. This is directions saying find the sine at pi over 6. It's not saying convert pi over 6 to degrees. Sine of pi over 6 and sine of 30 degrees have the exact same answer. because they're the same angle. It's just one is degrees and one is radians. The answer itself is not a degree or a radian. The answer is opposite of hypotenuse, or y over r. So what is the sine of 30 degrees? Stephanie? Good. Did you remember that from last time, or did you figure it out just now? You remembered it? Good. Because we have to memorize these. We have to have these memorized. We have to have these memorized. Malachi, what is the sine of 30 degrees? Okay, good. Katie, what's the sine of pi over 6? Good. See, there's the same answer. Same question, same answer. All right, so how do we memorize stuff? So I'm going to go back to how you were learning it, and I'm going to tell you how I memorized it. But you know what? Our brains don't always think the same, so maybe you come up with a more clever way of memorizing it. You know, maybe you make flashcards, I don't know. But we've got a 30, 60, 90. We also have a 45, 45, 90. And these are the ones you have to memorize. This is it for memorization. But you have to know all 6 trigonometric ratios for all 3 of those angles. So the first one we're going to do is 30. In order to do that, we need to know their side lengths, which hopefully, because you just took a quiz on it, should already be memorized. For 30, 60, 90, Caroline, do you know the side lengths, those formulas? Okay, what is across from what? Tell me where to start.
Adjacent to 60 degrees.
Okay, so you said x, adjacent. I actually think about across from 30 is the x, but either way is totally fine. However you remember it is good. And you guys, I'm not going to write x. I'm just going to write the number 1. I'm only writing the coefficient, which is, you can write x if you want. But I'm remembering 1x. And then, go ahead and finish. Radical 3. And then the hypotenuse is 2, right? The hypotenuse. All right, so if we need to find the sine, cosine, tangent, we need to know those numbers. So now the sine of 30 degrees, Brady, sine of 30 degrees?
1/2.
Okay, 1/2. That's all right. I was going to say, that one we should have memorized already because I've been saying it a lot. And if not, we need to get that one memorized. I'm going to tell you, I have that one memorized, and because I have that one memorized, I can find 8 answers knowing that one. If I have that one memorized, how do I find the cosecant of 30? Flip it. Okay, boom. So now I know the cosecant of 30. If I have that one memorized, that is using the 1 and the 2 from the 1, 2, 3 triangle. Cosine has to be the other side over the hypotenuse. So if sine is 1 over 2, cosine has to be radical 3 over 2. It has to be. So if I know that sine of 30 degrees is 1/2, then I know cosine of 30 is the other one, radical 3 over 2. And if I know that one, how do I find secant? Flip them. Okay, but when we do flip it, I'm going to do it up here. When we do flip it, we're going to have 2 over square root 3, but we have to rationalize that. So we do square root of 3 over square root of 3, and we get 2 square root of 3 over 3. So for that one, I kind of have memorized that when I flip radical 3 over 2, it's always 2 radical 3 over 3. I know I'm going to have to rationalize it, but I just kind of have memorized what it looks like rationalized, so I don't have to rationalize it every single time. So that's a half memorized, half just using the flipping thing. So there's 4 answers that I can get by just knowing the sine of 30 degrees is 1/2. There are 4 more, but it's not quite yet. Tangent of 30, I have completely separate memorization of that one. Tangent of 30, I'll do that one in a different color. If we look at the picture, tangent of 30, Lydia, tangent of 30. Okay, it is radical 3 over 3, or square root of 3 or 3, however you want to say it. What I memorized, well, let's do the cotangent real fast before I tell you. So the cotangent would be flipping before it was rationalized, so flipping 1 over radical 3, so just square root 3. So what I have memorized is when I'm doing the tangents, those are the square root 3's, but tangent of 30 is the one with all the 3's. It's the one with the 3 on the top and 3 on the bottom, and it's a 30. So it's the one with all the 3's. Tangent 30, one with all the 3's. That's how I have that memorized. You can pick your own way. That's how I have that memorized. So if I remember that one's square root of 3 over 3, then I can flip it to find cotangent 30. So that's 30 degrees. And then we do 60. So I told you the 4 purple ones, I can actually get 4 more. Knowing sine of 30 degrees is a half, I can get 8 total answers. So I already have 4 of them. So sine, cosecant, cosine, and secant, those are still in a 30, 60, 90 triangle. It's just the other acute angle. There's only 2 acute angles. It's the other one. So when I do the sine of 60, I do opposite over adjacent, or opposite over hypotenuse of 60, I get radical 3 over 2. And when I do cosine of 60, I do adjacent over hypotenuse, I get 1 over 2. So if we look at the sine of 30, the cosine of 30, then we look at the sine of 60 and the cosine of 60, what can we memorize here? I don't have to memorize them all individually. What can I remember between the 30s and the 60s? Lydia? They switch. And that's just because the angles are in the same triangle, so you're just looking at the other side. So the sine of 30 is 1/2. That means the sine of 60 has to be the other one, radical 3 over 2. Or the sine of 60 is radical 3 over 2, then the cosine of 60 has to be the other side, 1 over 2. We just need to really know that the 1, the 2, and the radical 3 are all in the same triangle. So if I know those two, then I can flip them for cosecant and secant. And if I have memorized when I flip, radical 3 over 2 is 2 radical 3 over 3. That saves me some time. I flip 1 over 2, I get 2. Saves me some time. So all of the pinkish purple ones, those all came from me really knowing that sine is 1/2 and the other side is radical 3. Sine of 30 is 1/2. The other side is radical 3. Tangent of 60 and cotangent of 60 are related to tangent 30 and cotangent 30. They're just switched. So when you go to memorizing these things, it should be pretty easy because all of those are the same for 30s and 60s. They're all the same. They're just switched around. So then you only have 1 more triangle to memorize. So the sine of 45 degrees, until we have it memorized, we look at our triangle. And Nathan, do you have the sine of 45 degrees? Oh, we didn't even write the formulas in. So we're going to do 1, 1, square root 2. So remember, sine is opposite over hypotenuse. So I'm going to do 1 over square root 2. Am I going to leave it that way? So rationalize it. What do I get? Mm-hmm. So the sine of 45 is radical 2 over 2. So that one has a square root of 2. In the other triangle, there's a square root of 3. So you shouldn't get triangles mixed up. What's the cosine of 45, Natalie? It's the same thing as the sine, because they are the same length. So they have the same ratio. And then when I flip those, I flip them before I rationalized it. The cosecant and the secant will both be the same answer, square root 2. So we just need to know the tangent and cotangent. So the tangent and cotangent are the two side lengths on top of each other, not the hypotenuse, the two sides. And Emily, what would that be? Tangent of 45? 1. So then the cotangent of 45? Also 1. So this one should be super easy to memorize. There's only like 3 different numbers we need to know. You have to get these memorized. You will notice that in your worksheet, there are like a lot of questions. There's a lot of questions in that worksheet. But that's because if I say, what's the sine of 30 degrees, you tell me half, like it should go fast. What's the tangent of 45 degrees? 1. So we need to know these. If you just look at the chart every time, you don't know them. You have to come up with them on your own. Is class over? No. We have like 8 minutes. So one more thing about that worksheet is it kind of goes in order of what we learned. We first just used triangles and found sine, cosine, tangent, and stuff from triangles. And then it uses the quadrantal ones that I just went over, that are the XY ordered pairs. And then it starts getting into things like, I know there's one on there that is the sine of 210 degrees. So let's review. We did this last time. Let's review how to do sine of 210. And I know this is what was rushed last time. I know I have it in the video, but you guys, we were rushed at the very end last time. So it didn't make it into our class. But I know it's in the video if you watch the video from 4.2. The sine of 210 degrees is on the coordinate plane. We're going to find 210. So if I start at 0 and I rotate to 210, which quadrant am I going to be in? 3. How far am I going into 3? 30 degrees. So what we have is we're starting at 0, 0, and we go x, then we go y, and that's our xy right there. This makes a 30 degrees reference angle. And that is the triangle that we would use. So if you need the numbers, you would start putting the 1, the 2, and the square root of 3 around here. But I'm really asking you, what's the sine of 30 degrees? Half. There's one thing wrong with just saying a half in this question. Sine is, theta, is y over r. And in the third quadrant, Courtney, in the third quadrant, y is a negative number. Like if I did put the numbers in there, we would have negative 1 over 2. So I don't need the numbers because I know the sine of 30 is a half, and I know that y's are negative in the bottom. So putting those two thoughts together, I can find that answer without writing down these numbers. That is our goal, is that we could find that answer without writing down those numbers. Let me pull one more out of my brain. I think this one's on the assignment as well. Cosine 3 pi over 4. So I'm going to draw this picture because I'm a visual person. 3 pi over 4 says take pi, divide it into 4 equal sections, and go through how many? 3 of them. And then I'm going to graph from 0, 0. I'm going to go left, up, and that's my triangle. So my reference angle goes to the x-axis. That's where I make my triangle. So my reference angle is what? You could say my reference angle is pi over 4. If we want to think about that in degrees, what is 45 degrees? Okay. So I'm asking you, what's the cosine of 45 degrees? Is that the final answer? Or, when we do cosine, x over r, where is x negative? In the second quadrant and the third quadrant. But if it goes to the left, this would be a negative number. So that this answer is negative. So the radius can be in any quadrant. Oops, can be in any quadrant because it's the radius of a circle, right? So if I have the radius here, or if I have the radius over here, it's going to be 2 no matter what. So the radius is positive, and we do. If we did tangent, it would be positive. Exactly, exactly. But just tangent or cotangent. Okay? If you need help, you send me messages. You come see me in XH. I need to get the answer key posted, or if we're uploading, I'm not quite sure what we're doing, but I need to get that posted because I have a class tomorrow. So it will be posted tonight. So if you have any questions, send me messages. It is your responsibility to know this stuff. I already know it.